Mel, who is going to talk to us about the issues related to 2.0 partnership and moving forward with from EGVIA to the new world of e-mobility in trying to be part of the wider system, to be the internet approach, the system approach. And so Lucy Bumel is director of EGVIA for 2.0, the association engaged with the European Commission of the 2.0 partnership. Since 2015, when she joined the Green Vehicles Initiative, she has been ensuring constant links between the association members, OEMs, suppliers, universities, RTOs, and the different European Commission services involved in the partnership, and is coordinating the activities of EGVIA for 2.0 members in order to disseminate the activities and achievements of the partnership. Before joining EGVIA for 2.0, she has been supporting Framework Program 7 consortium for 5 years in drafting and managing the research projects in various areas such as transport, health, and ICT. Lucy, we can hear you now with your presentation. And
Great.
can you share your screen, please?
Okay. Can you
Go
see my
ahead.
screen now? Okay, perfect. Can you just confirm that you are hearing me well? Because for sometimes I lost you, so yeah. I hope you can still hear me. I will just try to cross-check that everything is fine. Yeah, you can hear me? Venizelos?
Hear us,
Okay. Okay. Sorry,
no?
I didn't see the chat, but okay, now it's fine. So
Okay.
I will just start with my presentation.
Okay, go ahead.
Um, okay. Um, so. Um, So thank you very much for this invitation. I'm really pleased to be able to present to you the 2.0 partnership today and what we are aiming at with this partnership and what we will try to do in terms of interaction between road transport and the energy side and how we can maximize mutual benefit from research and innovation so that we can really accelerate the transition towards electromobility, also improving system integration and integration with the energy grid. Just in a nutshell, a presentation, very brief presentation of where the 2.0 partnership is coming from. We are not starting this partnership from scratch. We already had two previous partnerships as part of Horizon 2020 and FP7, the European Green Vehicle Initiative and the European Green Cars Initiative. And we really built the 2.0 partnership based on the successful experience that we had from these two previous partnerships. The 2.0 partnership is involving on one side the public side that is represented by several DGs from the European Commission under the leadership of DG Research and Innovation. But this 2.0 partnership is co-owned, let's say, by 4 different services, research and innovation, of course, but also DG Move, DG Ener, and DG Clima. So it's really the 4 main services with which we will be in contact. Of course, we involve many additional colleagues into the activities of the 2.0 partnership and the identification of priorities. We also have close contact with the GRC and CINEA, who also brought a lot of valuable input into our discussion. On the other side, the partnership is represented by a non-for-profit association that is gathering members of what we call the private side of the partnership, but which is actually much more because we involve in the association representative from, let's say, a road transport industry, so OEM, suppliers. We also have... Yes?
Your slides do not move on.
Okay.
Which slide are you on now?
I'm on the slide who we are. You cannot see it?
No. It's still the first one. So please
Yes.
check.
Okay. Yeah.
Can you
So
check which one it is? We are still on
uh,
the first one, huh?
it's a slide number. No, it's a slide number 2.
No. It's not. It didn't move. Can you check?
Okay. Um,
It's not in presentation mode.
really?
No, it's still on. Just
Okay. So let me just send 1 second. What I will do, I will not make the presenter modes. I will just try to do it like this.
yeah. So
So
now I think we see the slide. What do we want to achieve?
okay, so I will just go 1 slide back because I was still in this one. I will keep this mode. I hope it will be fine for you. I think you should see my
That's
screen
fine.
quite well anyway.
We can see it well. Yes.
Okay, good. So yes, we involve representative from let's say the automotive value chain with OEMs, automotive supplier, but we also have representative from the smart system, the smart grid. We have many research members and universities also members. So the association is really much more than the private side. It's not only open to private members, but really to all stakeholders that are active in research and innovation in the fields that are covered by the 2.0 partnership. For the time being, we have 99 members, and we see that there is still strong interest from several stakeholders to join the association. Anyone fulfilling the eligibility criteria can apply for the association at any point of time of the partnership. So this really remain an open initiative for the full duration of the 2.0 partnership. And the main objective really of this partnership, and as similarly to all the other co-program partnership, is to deliver research topics recommendation to the European Commission for the 2.0 calls. In addition, one of our main activities is to disseminate information as much as possible so that all stakeholders will be informed about the latest advancements in the state of the art and the achievements that have been done by funded projects, as well to promote all the activities from the partnership and the collaborative research cooperation that is building as part of the partnership. What do we want to achieve with this 2.0 partnership? Here you can see really the highest level objective that we have with this partnership. And you can see that, of course, this is well aligned with the different policy priorities that have been defined by the European Union in the past 2 years. The first point is, of course, to contribute to Europe having the first carbon neutral road transport system by 2050. This is really much aligned with the objective of the European Green Deal. So we really want to make the key contribution from road transport perspective to achieve the Green Deal objective. But at the same time, we also want to ensure European competitiveness and technology leadership all across Europe so that we can promote economic growth and also job creation all across the continent. And ultimately, we really want to have user-focused partnership. So improving the health and quality of life of the European citizen is really also one of the key objectives that will be driving the different actions of the partnership. And in order to do this, we structured our activities around 4 main pillars. These 4 pillars are constantly interacting with each other, so they are not standalone activity within the 2.0 partnership. They are really constantly exchanging and bringing discussions all together. So, of course, we want to keep on working on vehicle technologies and propulsion solutions, limiting the scope to battery electric vehicles for all types of vehicle from L category up to heavy duty, and also on fuel cell electric vehicles. Fuel cell electric vehicles will be limited only to heavy duty applications. But beyond purely vehicle aspect, we really want to put also the vehicle in its ecosystem and to promote the integration of BEV into the energy system and the related charging infrastructure, as well as develop innovative concepts, solutions, and services for mobility, both of people, but also of goods. And the idea is really that by interacting these three dimensions together, we could really build a system approach, an integrated perspective, and move forward with solutions that will be accepted by the user and accelerate the transition towards zero tailpipe emission mobility. In addition, we also want to promote LCA and circular economy approaches so that all the activities that we will undertake as part of the 2.0 partnership will be sustainable from the largest perspectives that you might have of this understanding. Of course, we are not planning to work in silo, and in 2.0 we will need to interact very closely with many other partnerships. You can see some on this slide. This does not reflect all the collaborations that we are planning to implement as part of the 2.0 partnership, but of course, we will have very deep collaboration with clean hydrogen on one side and the batteries partnership on the other side. Both of these partnerships will develop enabling technologies or building blocks so that we can promote the integration and at vehicle level within the 2.0 partnership. So there you can see there will be very close link between these three initiatives. In addition, we are also planning to have constant exchange of information and collaboration with the key digital technology partnership, which is a follow-up of Excel GU, as well as with connected, cooperative and automated mobility, interacting more with the mobility perspective, providing new mobility solutions. I just would like to go a little bit more in detail on the second pillar of the 2.0 partnership. And as I was mentioning, we try to identify some key challenges that should be tackled by the 2.0 partnership during the next 7 years. And as you can see, we really try to have these challenges being really user-oriented and user-centric so that we could really target the challenges that prevent the users from earlier and quicker acceptance of battery electric vehicles. And that include, of course, better charging solutions that would allow seamless integration of battery electric vehicle into the grid, meaning that charging should be easy, available at any time, and that charging duration should be also responsive to the different user needs. In addition, we are also planning to develop new technologies for charging solutions, such as smart charging or vehicle to grid. And there again, we can see also the interaction that will exist with new solutions that still need to be developed and deployed at a larger level. One important aspect will also be the interoperability, both in terms of physical interface and also in terms of IT system. So the idea is really, again, that for the users, this will be very simple and very straightforward way of recharging and trying to tackle the reluctance that some may face when it comes to longer travels where they will have no opportunities to charge at home, and the operability of the different solutions will really play a key role. Then we identified as next challenges new digital solutions that will improve charging planning. And there we can really see that there will be also a lot of connection between vehicle system and really the energy system. And here we need to define altogether the different solutions that will allow to have the most relevant solutions. And last key challenges is still to ensure power quality. And on this slide, you can see the different priorities that we identified in terms of research and innovation and the related demonstration and implementation phase that we planned for the upcoming 7 years. Of course, we have a lot of high priorities because improving vehicles technologies is one thing, but we really need to have better integration with the energy side so that we can really accelerate this transition. So there are a lot of high priorities in this. Of course, charging infrastructure is one of the critical one, and we hope that there will be a really strong acceleration in the coming year in terms of charging infrastructure deployment as well. You can see the very last point is related to fast, high power charging. This will not be relevant for all use cases, but we really want to address the different charging needs for different users. And this will be also critical for some very specific use cases. And this is really important that we also anticipate and develop solutions that will be able to provide the necessary developments so that we can accelerate the transition also for heavy duty applications, for example. You can see again the interoperability. This is again something that might also take some time. So this is really important that we start as early as possible so that we can really accompany the transition and the acceleration again. And the system approach and the planning of BEV connectivity will be closely interacting, of course, and closely linked with each other. And this is really the paramount that we need to implement so that we can make sure that we at the end of the 2.0, we really are able to say that we managed to implement this integrated system approach. So there you can see that it's quite ambitious. We have not so much time in the end because we already published, as you know, the first work program of the 2.0 partnership for 2021-2022. There is one topic that is dedicated to system approach for charging of BEV. But there will be really a lot to do and not so much time. So we really need to start as early as possible all together so that we can really take the lead also in the race for the integration of battery electric vehicle into the energy system in Europe and also beyond. That's it from my side. I hope it was clear what we are aiming at with the 2.0 partnership and what are the different areas where we will investigate closer collaboration with the energy side. Thank you very much.
Yes, thank you very much, Lucy, for this interesting emergence of the 2.0 partnership and what is promising to be the European answer to the energy transition of the mobility, something that so much a task and a need in this transition evolution. We will have time to discuss further these issues later on after all the presentations are put forward. So if we have Jose on the line, do we have him? Not yet. So instead of Jose, let's move on with Evangelos Garfopoulos, who is with us here to address issues related to e-mobility, the research perspective. And the Evangelos Karfopoulos received the Diploma of Electrical and Computer Engineering from the National Technical University of Athens in 2006, and he received the PhD degree for his research on the optimal management of electric vehicles for their efficient and effective integration into electricity networks. This is back in 2017, correct? So let's hear from Evangelos, who has worked on these issues during his research life, which gives us a good evidence that we will hear the touch of research in these fields. And I think his his approach on research and innovation requirements for e-mobility is something that is of high interest to all of us. So, Evangele, you have the floor.
Thank you very much, Mr. Venizelos, and for the introduction, as well as for the invitation. It's an honor for me to be here and provide the research perspective on the mobility aspects. Um, Hello from my side. This is Evangelos Karfopoulos, and the presentation today aims to give the research perspective on different e-mobility aspects. In some more details, the context of the presentation, I will initially make an introduction of our research team, and then I will try to give the research areas as well as the challenges that the research programs at EU level aims to tackle based on the users' concerns, um, considering not only EV users, but also non-EV users in order to understand why we don't have the transition from the conventional vehicle to e-mobility that we wish to have. And finally, based on these users' concerns and the challenges that we wish to face, we will have travel back to 5 or 6 years ago in order to understand in research area what are the products and how the tools that are produced at the research level aims to tackle all these challenges. Uh, iSense Research Group is one of the largest research group in the ICCS and under the National Technical University of Athens, with more than 120 researchers with more than 20 years of research experience. We are covering different research areas from intelligent transportation system to communication and insertion systems, environment and circular economy, crisis and disaster management, and of course, last but not least, e-mobility, electromobility aspects. There are two main research areas where all the research projects focuses and can be split in two uh, axes, the technological one and the systemic approach. In the technological level, the scope is to identify the technologies from the vehicle point of view, as well as from the infrastructures that will allow users to realize the transition from the combustion engine vehicles to electric ones. So we need technologies that serves EV users' charging needs for mobility concepts, but also to ensure interoperability of the technologies. And these technologies should be efficient with low losses and low cost. In the systemic approach, we have two different areas. The services that needs to be provided to the users in order to facilitate the accessibility as well as the exploitation of the charging networks, but also to ensure that the additional demand of the charging process does not affect the smooth operation of the electricity grid in terms of technical and financial aspects. Which are the users' concerns that are the drivers of the research, all these research topics? Three main concerns have been identified. First of all is the cost of the electric vehicle. It is true that the cost of the electric vehicle compared to the conventional one, mainly due to the battery cost, is already high, even though the battery cost is degrading compared to 10 years before, still the electric vehicles are much more expensive than the conventional one. So we need to focus on incentives at national level and subsidies in order to promote e-mobility, and also focus on new tariff schemes in order to promote e-mobility at national and local level, at city level. The second concern is the change of habits. It's difficult to change old habits. We all born knowing that we are driving conventional vehicles, that we can refuel them in a few minutes. Now we have to change to more environmentally friendly electric vehicles, but the charging process lasts longer. Uh, it's difficult to change habits, but we should consider the great paradigm of the telecommunication area. We all remember that beginning of 2000, we have conventional phones that which the full charged battery could last more than a week. And then we have the change at the end of the first decade of 2000 with the invention of the smartphones, which battery could last only approximately 1 day. Even though we have this difference from 1 week to 1 day, I think that the majority that are connected here and follow us have a smartphone. I'm sure that less than 5% have a conventional phone. The idea is that, and the reason behind that justification is that the benefits and the services offered by smartphones are much more uh, helpful for the user than the battery duration. So we need to communicate to the users, to the drivers, the benefits of the electric vehicles from all the aspects, financial, environmental, and economical. Last but not least, one of the main concerns is the range anxiety of the electric vehicles and the location and where they can charge the electric vehicle. We need to facilitate users to have easy accessibility to the charging station prior to the charging process. We need to improve the charging experience during the charging process, and we also need to support users after the charging process. We need to provide them interoperability, accessibility, and exploitability with enhanced information to the charging network. In this slide, I will try by presenting, outlining the main outcomes in 4 projects. The 3 first ones have already been completed, and the last one is in progress, it's in the second year. The aim of the presentation is to give the main outcomes and the main products and the tools and the services that aims to provide answers to the 3 previously mentioned users' concerns. Starting with a fabric project, this aims to provide new technologies apart from the conductive that are already very well known to most EV users and to all of you, to provide an alternative, which is the inductive or the well-known wireless charging. By this, the vehicle is capable to be charged while driving with 20 kilowatts power, charging power, with a speed of more than 100 kilometers per hour. This will facilitate the charging of the vehicle and will enable the long trips, not only for inner city mobility, but mainly for intercity, limiting the range anxiety raised by the users. And the project aims not only to provide the technology, but also to examine the business models as well as the sustainability of such technologies in real life. The second project is the NEMO, which aims to give a product, that an open source product facilitating the roaming on the services. Interoperability is not only in the infrastructure is very important, but also interoperability in the actors that exchange information and provide services to the users is also really important. The scope of this project was to develop a decentralized hyper network of protocols that allows users to be connected seamlessly to the infrastructures with one RFID card, similarly to the telecommunication network reflecting the use of mobile phones. With one SIM card, with the same mobile phone, you can travel around Europe without concerning how you can call your family without any issue. The same problem should be transferred here, and the experience from the telecommunication area is the best, and the best practices should be considered in the definition of the roaming services in the mobility area. Just to mention that the platform provided by NEMO, it's an open source and has awarded with a first place in the International BOMI Grand Challenge in America. The third project is Exhibiton, which studies something different. It studies the sustainability and aims to promote the micromobility in urban context in terms of technologies for light electric vehicles, e-bikes, or in generally L1 and L3E vehicles, and also promote the car sharing concept in order to reduce the capital cost of owning an electric vehicle. The project has demonstration of 100 light electric vehicles in 6 EU countries, and this can benefit everyone, all the stakeholders, because a large data set is available for the usage profiles of the light electric vehicles, as well as the responses from the user questionnaires, the online, that can give business models and guidelines how light electric vehicle and micromobility concepts can be deployed at urban context for private and commercial mobility. Finally, the Charge for Driver project is an ongoing project. Is in the second year of its life, and this project has this specific difference from the previous one. It aims to provide user-centric technologies and services. The user is at the very center. The user is the one that defines the requirements, the needs of in terms of technologies and in terms of services. And when we are talking about users, we are talking about drivers from conventional as well as electric vehicles. We should identify what are the difficulties EV users face during charging, what services they need to access and exploit charging infrastructure, but we also need to hear the drivers of the conventional vehicles in order to understand why they have not yet been owners of an electric vehicle. The project aims to design different technologies and services. Indicative examples are modular ultra-fast charger compatible with ISO 15118 plug charge in order not to have the issue of the RFID card and authenticate and authorize the vehicle itself and reduce the interfacing of the user with a charging infrastructure. We are developing bidirectional DC charger based on the ISO 15118 protocol again, multi-outlet charging technologies for passenger light electric vehicles in order to minimize the infrastructure costs, mobile charging station and services in order to promote and facilitate the charging of the user in areas where the charging network is inadequate or not well developed at the moment, battery swapping stations for light electric vehicles, which can promote the battery as a service or the battery leasing concept, booking, routing, and smart charging services. Finally, the charging location planning tool is developed in order to allow authorities and CPOs to better plan and extend the existing or better plan the development of the charging network in order to minimize the cost and maximize the benefits for the users. We also aim to provide open source interfaces for the ISO 15118 plug and charge concept in order to facilitate the deployment, not only from the OEMs, from the EV manufacturers, but also from the charging point manufacturers. Finally, moving from the past to the present and now to the future. What is next? The research topic to the next is the smart charging and how electric vehicles can provide flexibility capacity by providing energy back to the grid. We are examining the battery of the electric vehicles as small as distributed batteries with limited capacity. Thank you very much for your time.
Thank you very much, Vangele, for this presentation. We are, of course, ahead with research and innovation in these fields, and there is a lot ahead. And I'm sure that e-mobility is moving in the correct direction, as we have heard already, and we will discuss it further today. I think we are successful, and we have Jose on the line. And Jose, just say hello to us.
Hello, can you hear me well?
Yes, we can hear you well. Thank you very much for being with us. And we have Jose Oliveira coming from Eneida, a company in Spain, and he's going to talk to us about Deep Grid, Eneida Deep Grid, secure supply of the e-mobility transition. And so he is uh, involved with the Eneida, the company, for 5 years now, working in the research and development as a manager there. And so in the last years, he has been working on low voltage grid optimization with focus on distributed energy resources integration and low carbon technologies adoption. And he has coordinated the ENEDA participation on several innovation projects nationally, but also internationally. In these projects, ENEDA has been developing and delivering smart sensors and web applications based on big data analytics and recommendations algorithms. And so we can definitely have someone who is really in the hardware level of contribution into this e-mobility. And we're very happy to hear you, Jose. The floor is yours.
Okay, thank you, Venizelos, for your kind presentation. I'm glad to be here with you to present, to talk about.
Yeah, please try to share your slides.
Okay.
Yeah. And see if you are successful.
Okay, I think it's there.
Yeah, we can see it.
Yeah.
Okay.
Okay. Thank you. It's a pleasure for me to talk about ENEDA and what we are doing in the secure supply in this transition to e-mobility. I briefly present ENEDA. We were founded in 2012. We have been working with close collaboration with the University of Coimbra and the Portuguese DSO and TSO. And from there, we started to develop several solutions to low voltage networks to optimize the infrastructure exploitation. We are now working in several countries in Europe, Africa, and Australia. The markets where we have more clients and from where we have the major revenues are the UK and the New Zealand. On the first one, the UK, we have been developing a lot of features concerning congestion management and EVs uptake. Australia and New Zealand, we have been developing features more related to PV hosting capacity. So new electric appliances such as mobility, but not only, and distribution generation brings a lot of uncertainty into the LV grid. And our mission in this context is to give each neighborhood the intelligence it needs so to achieve ZEN, zero emission neighborhoods. How we do this? We equip secondary substations with a very low-cost sensor, and we provide the DSO with the visibility of what's going on in the grid and predict what's going to happen tomorrow. Then we use that data to feed our LV apps to enable voltage and demand control and coordinations of there in the grid. In close collaboration with the DSO teams, we make our road to achieve zero faults network, so secure the supply. We do this over our platform. ENEDA Grid is an open platform running LV apps from different partners, consuming all available data in the DSO data lakes to optimize and control the LV grid, so we can have an affordable, reliable, and sustainable neighborhood grid. To manage congestion, to control the demand, and even to curtail the available power on the EV chargers, if we going that way. To do that, we use smart sensors in feeder pillars. We use our deep grid platform to manage data, and we use mainly two from our low voltage operational analytics applications, which are congestion visibility and capacity optimization. So our sensor measures current and voltage in LV feeders, and with this data we can work a wide range of use cases with the distribution operator. The sensor, of course, it can communicate with all platforms with several protocols. It measures all relevant energy parameters from the feeder pillars. And based on this data, in particular in the congestion visibility low voltage app, what we do is ranking substations and feeders as well by power occupation. And we have in a glance visibility on how many substations are recording higher congestion levels. From these plots, we can select substations that record higher mean values in the evaluated period, a week or a month. We can click on one of them to navigate to them. And now in a particular substation, we can see the mean and maximum values per hour in the analyzed period. In this case in particular, we have a power occupation above 70% at 5 and 6 p.m. in the last 30 days. So with this app, this app provides us with different KPIs and analysis. In particular, it allows us to perform load disaggregation and find out what feeders are facing higher growth in the EV charging, for instance. We can also trace an evolution of EV charging events and also forecast EV charging events. By computing these load profiles, harmonic distortions, and cross-checking with the public chargers data or available EV chargers data, we can count charging events per feeder and phase and per period, and we can rank feeder phase pairs with higher charging events per period. Then, by adding on the top of this the expected demand profiles from new EV chargers, public or home EV chargers, we can correlate all these data and provide the municipality or the distribution system operator information of what are the best feeders to connect new EV chargers and how many. Once e-mobility is largely adopted in the near future, I suppose, we can also provide the DSO with the information to take some actions. So we are already forecasting the demand per feeder and per phase. We are already forecasting the contribute or disaggregate the contribute of EV charging in this expected demand. And based on this, we can compute the recommended power curtailment in each circuit and period of day in order to avoid the outages, in order to secure the supply, in order to guarantee that we can use electric mobility, ensuring a reliable low voltage network. And that's it. Thank you. Thank you for listening. I'm available if you have any questions.
Yes, thank you very much, Jose. Hello, can you hear me? Yeah. Thank you very much for this interesting approach from the angle of the system, because to use charging in a smart way, you have indicated how that can be achieved within the distribution level, within low voltage networks, that's where it's being charged. I mean, the majority of vehicles are going to be charged. And so, yes, we will have more time later on to discuss all these issues. But before we go there, we have with us a real user of an electric car. He told me, Luciano, here next to me, Luciano Martini, who is the chairman of ERA Joint Program for Smart Grids, and also he represents Europe and Italy in the mission innovation with a lot of activities in various fields. And he, of course, successfully represents his company, RSE, in Italy, and he is already a user of electric car. He says he got it in his company and he's using it every day, and so we can hear real life um, experience in this. So the floor is yours, Luciano. You can say more.
Thank you very much, Venizelos, for the kind introduction. Yes, I'm still very new about electric car. This is just 1 week, but this is a big change. We electrify our company fleet, and we are now using the fleet also for testing, not only for recharging the cars at the company site, but also at our premises in our houses. I'm trying to share my presentation, and it takes maybe 1 more minute. I don't know why. Oh, now it's perfect. Very good. Can you see my presentation now? Okay. Okay, so thank you very much. I would like to thank Venizelos for inviting me to this event. We, as RSC, are a proudly member of the Pantera project, and I was very much keen to contribute. It's possible because of the topic of electrification of transport is really one of the hot topics that is also changing energy strategy in different countries. I will tell you what is happening in Italy in a few words. I was saying that this activity is really involving 4 different departments of RSC. The one is dealing with the environment impact, because of course you reduce emission in the urban region. Is also the one that is making scenarios and trends. So because you are really having to estimate how many cars will be really traveling in your country in the coming years and decades. Is also involving the people from the grid side, my department, because we are really looking to make sure that the electromobility is becoming an opportunity more than a challenge for the present grid and so on. Technology about batteries is also studied at RSC. I will be quite fast, but I would like to give you at glance what is happening right now. So first of all, the Italian National Energy and Climate Integrated Plan give a lot of importance to the development of electromobility. So in our present plan, that will be updated soon, so with even more ambitious target, we already have a figure of 6 million electric vehicles by 2030. 4 million of them will be battery electric vehicle and 2 million being plug-in hybrid electric vehicle. And then, as you know, all electric vehicles are coming with a large battery pack. We have a 50 plus kilowatt hour per battery pack. For example, my new car is 82, so it's even larger. But this is just to say that if you plan for this 4 million battery electric vehicle to support the grid, we really have a very large amount of energy that could be made available to support the system and also to allow for even a higher penetration of renewables, because you can really use the car to mimic or to support and to use energy when it's available from renewables, because you can have, of course, a self-consumption. So you have PV generation, maybe the load is not as high as you would like, so you can charge your car. And then, of course, the load from the electric vehicle, aggregated electric vehicle, could be really flexible enough to mimic the load profile to improve the situation, to avoid excessive burden on the grid. So I think our colleague was also mentioning about the importance of having the driver at the center, the consumer at the center. This is exactly the right philosophy. Of course, it's important to put incentive of electric cars. So in order that when you buy your new car, you have an accessible price. But you have also to improve experience of recharging. You have to take the problem from having a car that with limited range is not a problem anymore, because you have a nice infrastructure, and then you can recharge your car at different places in different modality. You have also some solution to make the recharging maybe nice, in order to make people having a short time dedicated to something in particular before your car is fully charged and you can start again with your trip. In this chart that we prepare for ENTSO-E, for a position paper that was released sometime in April, that is still available on ENTSO-E website, we really had a possibility to look at the entire ecosystem that is around the electric vehicle. As I said, the end user and the electric vehicle user is at the center, not literally in this chart, but it's the center of everything. The center because is the owner of a car, is the one that is allowed to make a charging at different modality at different places, is also in contact with a charge point operator, and is the one, of course, needing the car for his own need and benefits. But of course, the whole ecosystem is very broad and entail really the full system from DSOs to DSOs to other players that, of course, need to make sure that the full rollout of electric vehicle is possible in our countries. This is something that is happening in Italy. You see some preliminary data here about 2030. So it's about the type of infrastructure for electric vehicle charging. We have a plan that is an estimate of 3.3 million private recharging points. And of course, we need also to have a public fast recharging station in order for people that want to travel long trips also to be able to recharge the car in a shorter time. Most of these charging fast charging station will be in urban center, but we will have, of course, also this charging station for fast recharging along freeways in order to make longer trips, and also on extra urban roads at both national, regional, and provincial places. What is also important is that we will have a large amount of public slow charging station. In this is an estimation from RSC, about 78,000 more charging station in the public. These are very important because if you want really to support the grid, you have to look to this slow charging because the car will stay for a longer time connected, so they can at the time charge the battery or at the time support the grid if they have a vehicle to grid functionality. I will come to this point in a moment. So first of all, vehicle to grid. This is really something that we are aiming to, is bi-directional, and then you have an installation that use a possibility to receive a controllable sign from external players that tell you when the car can recharge at full speed or when the car can support in aggregated form of force the system. Then you have also the most typical case of a vehicle to grid, so modular monodirectional charging. In this case, we call it smart charging because it will be extremely bad if a car will be charging exactly when you have a peak hour for the load. So you have to be able to make possible that the car will be charging when plenty renewable energy will be available and when the load will be at the same time quite low. So in order to smooth the peaks and the valley of the load profile and make the system easy to be managed. This is something that I think is quite important. It's still a kind of experiment that is allowed by the Italian National Regulatory Authority for Energy and Water and transportation. In this case, we are planning to allow people to charge their car during nighttime with double the power that is usually allowed at your household. So we have in Italy 3 kilowatt installation that can be also run to up to 3.3 kilowatts, so plus 10%. After that, your main load will be disconnected. But the proposal from the National Regulatory Authority is that in daytime from 11 p.m. till 7 a.m., you can use your smart meter in order to charge your car in a more efficient way with much more power. Of course, this will be provided with no extra cost. This is quite important, but only in case that you use this possibility for charging your car and not using for something else. I think this is a smart solution because it will not entail any changing in your house. You don't have to change your ground system. You don't have to change your smart meter, just using at best the possibility because, of course, the load nighttime is much lower. Okay, so I come to some final remarks. I think the scenario by 2030 is now under consideration in Italy for an upgrade. We have a very ambitious target already, but because of electromobility, because of the target for deep decarbonization by 2050, we will even increase our targets, also take into account the possibility and the contribution from hydrogen and all the hydrogen value chain. And then, of course, the functionality, vehicle to grid. I think also Lucy was alluding to this very important functionality that make really the electric vehicle support in the system. And this is something that we really have to make possible. There is also some activity that is at the regulatory side to allowing some maybe simple solution that make the rollout of electric vehicle possible and accelerating this process as much as possible. We as RSC are also developing some second generation wall box that will allow the consumer to really define which is the profile on which the car will be charged according to their need, according to their plan for future traveling and so on. And of course, I will maybe have during the discussion the possibility to share some of the activity that we are also doing at RSC at this time. And Venizelos, with that, I think I would like to stop with my contribution and I become available for discussion. Thank you. Back to you.
Thank you very much. Thank you very much, Luciano, for this and for this update coming from Italy side. And I think the fact that we see millions of electric vehicles coming 2030 as a target, 6 million, even though the four will be battery and the two will be um,
Plug-in.
plugged hybrid cars. I think this is a very good signal that countries are taking it seriously, and that's very important. So I have a presentation as well that I would like to share with you before we continue to our discussion. And I will try to share my screen. Seems that I have many open and it's not seeing it at the moment. Just a second. I'll shut down a few things. Let me see. Okay, let me see now. Share. Okay, do you see it now? Let me see. It's coming. Yeah. Okay. Good. Yep. Let me. Okay. Now it's okay. So we are indeed in the fifth Cretan Energy Conference International that we are having here in Heraklion, Crete. And I would like to look at the angle of electric mobility as an efficient, economic, sustainable, and flexible way of being mobile. I think, I don't know, most of the people in the room are here, but maybe we have connected people that maybe they don't know me. So I have to say just a few words. I'm the chairman of FOSS Research Center of Cyprus, and I'm also chairing one of the working groups of ETIPSNet back in Brussels, and we are helping 2.0 partnership to go live and be operational now in this work. And so I have contributed in that direction. And so in that respect, we are well aware of where we are going with 2.0 and we are fully supportive towards it. And we know that 2.0 has come up to stay and is going to stay and contribute in this vision for a clean planet by 2050. We all know that things are changing, the weather is changing, we are really feeling it. And if someone says he's not feeling it, I think he's lying. And so in that respect, we are trying to keep the temperatures below 1.5 degrees rise, but we are already in a bad shape at the moment. And we would like to see no emissions by 2050. And in order to achieve that, we would like to see the Green Deal being really fulfilled and really met. And one of the important items of it is e-mobility. And so we would like to see a long-term strategy in that direction, and we would like to see a sustainable energy for all Europeans. This is what is meant through the Green Deal, and to ensure sustainable, secure, and affordable energy supplies in the European Union and fully integrated. That's why we give so much importance to e-mobility integration into the system approach, as we call it. And through the integrated emerging technologies and common energy market rules facilitated through cross-border infrastructure that can optimize the use of sustainable resources in the EU, meaning that energy can be produced in one EU country and delivered and used in another country in an optimal way. So cooperation and collaboration is key in this area, and this is why the EU funded project Pantera, that we are coordinators, we as FOS, I mean, we are coordinators, and we are here in this Cretan conference area as Pantera, trying to raise the interest of policymakers in helping research and innovation, in picking up and strengthening in the direction of helping this energy transition. And we have tomorrow uh, a presentation of the work that we are doing through Pantera. And please connect with us tomorrow at 10 o'clock local time, 9 o'clock Central European time, in order to hear about the ERI platform that we have put forward and is already functional and operational, and why you consider it very important for research and innovation community in Europe to be aware, to be a member, to be an active contributor to the ERI platform, because through it, we like to bridge the gap that already exists, that currently exists, not already, currently exists within Europe as far as research and innovation, data, information, knowledge, and capabilities of helping each other in this direction. We are part of Europa. We are within JRC's Smart Energy Systems area, and we are building something for the European Commission, but for the Europeans. And so please join us tomorrow, and you will hear much more on this issue. Yes, this is the vision of what the Pantera is aiming through. And I'm not going to stay long on this, because I would like you to join us tomorrow. And we have this overall view that we have put forward, that we would like to see the process within the ERI platform to give us the capabilities of evaluating progress through research and innovation, how that affects technologies maturity, how maturity of technologies is helping the maturity of functionalities within Europe, and how that generates the new research and innovation needs in order to help the work program, including 2.0 work program, how and what are the requirements in order to move forward with the next implementation plan, the next 10-year plan, the next Horizon Europe plan. So, and of course, all that, we are trying to do it with the area that is encircled around smart energies, smart systems, storage, and local energy systems. That's where ERI is centered, and that's where e-mobility is centered. E-mobility is centered around these areas, and that's how it's going to be effective, functional, and operational within the system approach. And as you know, we are moving forward with the smart grids. We have heard it quite a lot these days, and I'm very happy about it. Even the minister this morning was talking about the smart grids and the evolution of the smart systems, because I think that's where we are going to maximize the benefit of utilizing these energy transition issues. And so the efficient use of available resources on our planet and how we can boost flexibility is something that we have heard it from earlier speakers, the importance of approaching the e-mobility from the flexibility angle. And that's why we give it a lot of importance. And we know that it affects the related operational needs of the system. So attempting to match the flexibility sources and flexibility needs within traditional organizations, silos as we call them, as illustrated in the figure, would likely lead to considerable overinvestment in each silo in comparison with more innovative solutions that would aim to capture synergies across and between silos, because that's what is important. And that is why it's critically important that 2.0 partnership is successful, because it's not just making a car efficient and effective within the car. It's much more efficient if it's linked with the system, and we utilize the flexibility that it offers and the generation of resources that it offers to the system for the benefit of the whole system, because then we achieve optimal solutions. We achieve the lowest cost possible that is giving to the whole system a better performance for everybody. And this helps also, of course, the users of the cars. So decarbonizing the economy means more renewables and more electric vehicles. Future power systems will be increasingly based on variable renewables. Future transport systems will be increasingly electrified. This is what we see, and this is what we expect to be happening. So the future may see an integrated emissions-free electricity and transport system with renewable energy powering not only grids, but also electric vehicles. And electric vehicles represent a paradigm shift from both the transport and power sectors, with the potential to aid the decarbonization of both sectors by coupling them in an urban context. In particular, cities can benefit from decarbonizing transport while greatly reducing air and noise pollution, as well as fuel imports, and providing new technology options to rethink the urban mobility issues. So just as future transport must be increasingly electrified, future power systems must make maximum use of variable renewable energy resources in order to move towards what we have called quite often and what we have heard already, the smart charging approach that minimizes the load impact from electric vehicles and unlocks the flexibility to use more solar and wind power in the system. And what is currently the system? We are seeing electric mobility rising in many countries, and we see examples in this figure, and you can take it with you. And this is growing. We have heard the example of Italy, what target they have indicated. And we have seen many countries putting high millions of electric vehicles being with us by 2030. And so this shift towards 100% electric mobility is a reality today. It's something that we see it happening. There is political push for this. So the EV100 initiative that was launched back in 2017, and it was launched then, encourages companies to commit to moving towards 100% electric corporate fleets and to install charging infrastructure to support them. So after several months surpassed, the initiative had signed on 10 multinationals, among them the Swedish power company Vattenfall, IKEA Group, and Chinese internet giant Baidu, that they have all joined this call for 100% electric mobility. So Vattenfall has the most time-ambitious goal of the initiative so far, with the company setting targets to shift its fleet's 3,500 light-duty vehicles to 100% electric by 2022. Can you imagine? Okay, RSE has taken a decision and is going in the correct direction. But we are seeing many companies doing that around the world, and they're putting the level high where it should be. So the French postal service La Poste is also a pioneer in the field, owning 35,000 EVs out of the total fleet of 75,000 vehicles, and is moving in the direction of being 100%. And Germany's Deutsche Post DHL group also set the target to achieve zero emissions logistics by 2050, in part through the use of electric vehicles. So we are seeing things happening around the world. And so advantages of electric vehicles for the transport sector. So electric vehicles have three main advantages for the transport sector. First, they run on a cheaper fuel, meaning that the per kilometer cost of electricity are typically lower than those for gasoline or diesel. And second, EVs emit no local pollution. We know, and we are experiencing it. It's noiseless, it's emissionless. So, and the third, the energy efficiency of an electric powertrain is much higher than for internal combustion engines. And we are talking about 3 times. It's not, 1.2, 1.5%. 120, 150%. We are talking about 3 times more efficient. So, however, to accomplish true decarbonization of transport via electrification, the electricity used to charge the electric vehicle battery packs should be produced from renewable sources. And we know that we are doing a lot in this direction. And I think together with smart charging, this is going to be a key winner in the years ahead. So electric vehicle flexibility potential is something that we need and we must explore. The uptake of smart charging for electric mobility is expected to establish a positive feedback loop with the integration of renewables, given that e-mobility is a power-dense, mobile, and controllable load. Studies have shown that cars in general, including electric vehicles, are parked for about 95% of the time. You can imagine that the car is idle for that time and is plugged in, so available for communication usability of the system. So this, combined with their storage capacity, could make electric vehicles an attractive flexibility solution to support system operation. So they can become grid-connected storage units with potential to provide a broad range of services to the system. And so IRENA has done a study in this direction, which is very important. And listen to the figures. We are talking that by 2050, 14 terawatt hours of electric vehicle batteries would be available. And I think it's even underestimated. I expected a bit more, but IRENA has given this number, which provides grid services compared to 9 terawatt hours of stationary batteries. So you can imagine that by 2050, we are talking about 1.5 times more car batteries than stationary batteries. So storage in battery storage is going to be a key winner in this process, and it's going to be even higher. This is what I expect. So by 2030, we will see flexibility coming from various directions usable. So individual ownership of cars and vehicles, and that's why it's limited to 2030, because it's expected that until 2030, we will see an evolution into electric mobility, but on personal capacity, owned by us, in other words, owned by companies. And having this car, as a result, an increase in the capabilities that it offers, the flexibility that it offers. And so more EVs available to the grid due to falling cost. We will see that. Electric vehicles get cheaper due to falling battery costs and government policies. Bigger batteries helping to overcome, and we will see this as well, shifting from today's, let's say, 20, 30 kilowatt hours. We are already moving higher. How much is yours? 82. 82. We are already there. But we are talking about a level of 50, 60, 70 kilowatt hours for the family cars, the normal family cars. But we will see bigger sizes as well. And you know that the average consumption in our homes, when we are talking about 50, 60, 70 kilowatt hours, we are talking that what we consume in a house, a normal average house, is about 10 kilowatt hours, or let's say 12 kilowatt hours per day on the average. And if we have 2 cars in a home, we are talking about 100, 120 kilowatt hours, out of which only 10, 12 kilowatt hours we need in our homes for our daily energy needs. So you can imagine that the car can play a key role in how we manage energy within buildings, within homes. So cars, charging stations, smart charging and discharging functionalities, as standardization progresses and as the requirements for better control of the charging powers increases, the vehicles and charging points will have smart charging options, including discharging as a common feature and technically enabling provision of ancillary services to the grid. We have seen before, coming from Lucy, the presentation that it indicates that we are moving towards smart charging in the short time future, not long time future. And so we will be seeing this happening on the systems. The question is, how smart is the grid in order to accommodate it. And I think utilities are running a bit behind. Technologies are here with us. We have them, but we are running a bit behind with regulations and with grid rules and the utilities investing in them. And I think here is a key priority that regulators should look into it and help countries to evolve in that direction. So electric vehicles providing power system flexibility by 2050. And hear this, that between 2030 and 2050, this picture could change substantially because mobility business models, such as mobility as a service, is coming. Not owning, but receiving it as a service. And this is within the priorities of 2.0 partnership as well. We are going to see this shift towards mobility as a service coming not after 2030, but after 2030. And this will give us technologies such as autonomous vehicles may emerge in addition to this and be broadly implemented, leading to a shift from individual ownership to vehicle to fleet management. Studies have shown that ride sharing could lead to an increase in the number of kilometers driven as the shift from public transport towards shared private transport occurs at a larger scale. And this will definitely shrink the number of e-vehicles available because we are going to make more use of electric vehicles, but in a shared way. And this is going to happen. So the impact of e-mobility evolution on flexibility parameters between 2030 and 2050. This is something that I have listed here for you because when, where, and what, and how much, and how long is something that we have to answer, and we are seeing it more and more, and you will see all the answers here in this list of what is expected at this level of knowledge and this level of development of our technologies, or in this level of understanding as well. But you know that things are moving, are shifting, and we will see changes in that direction as well. And so an example of time of use charging, obviously this is going to change because the energy mix is changing, is shifting. We will see more solar-related generation in the future than what we currently have. And so, but the load continues to be, as you see here, off-peak. In other words, low demand is in the evening from, let's say, 11, 12 hours, midnight, to early hours of the morning, 6, 7 in the morning. And partial peak is in between, and we have a peak normally between early afternoon to, let's say, 8, 9, when people come home and they use, and it goes even 10. And in the summer that we stay longer, it goes even up to 11 o'clock, the peak of the demand. So this, of course, we have to adapt it to how we will utilize all this equipment, depending on how we will grow in this direction and what sort of energy mix we have in order to respond to this shifting towards the early peak of the evening, or how we can manage that. Because if we depend, let's say like this, that is showing that we depend on generation coming from solar, this is happening during the day. But how are we going to utilize this in order to be efficient and effective and not end up utilizing other types of generation in the early evening when we have the peak? The suggestion here is to use storage as a solution. And e-mobility offers this flexibility from the vehicle to grid technologies that are already with us, not though commercially available to the degree required. But by 2030, we will have it, and to a higher degree, and this will grow faster towards 2050. So possible electric vehicle revenue streams that can be stacked. And you can see here a very important parameter that we will have to use in the future, and how this can benefit. And this is what I was talking about before. when it's part of the system, there is a lot of services that will be utilized within the system, because all that storage that is available is going to be utilized for fast frequency reserves, primary reserves, secondary reserves, congestion management, and via load shifting, peak shaving, voltage control. And so these needs, not talking only energy arbitrage that is going to be utilized. We have a lot of other needs of the system that we can capitalize on and utilize and give revenue back to the provider. That's why system approach is going to shift us towards low cost e-mobility that is going to be not only more efficient because it's going to use more efficient machines and more efficient use of energy source, it's going to be also a lower cost because it's going to benefit from all these services. And so we have heard from Lucy how we have shifted from green cars to green vehicles to 2.0, and how a synergy of these novel concepts for the distribution networks, the propelling of renewables integration, the smart grid deployment, and demand-side integration schemes have to be coordinated harmonically in order to accomplish the EU targets for the climate change towards the transition to a green power system and the efficient use of energy through further electrification. And this 2.0 partnership, we have seen how this will help and how sustainable development goals of this can benefit us, and by drastically reducing CO2 and other greenhouse gas emissions from road transport, how supporting the development of multiple solutions, alternatives to conventional vehicles and the related recharging, refueling infrastructure, while leading the way to use the 100% renewable objective, by improving air quality in cities, and we have heard about that, and by reinforcing European competitiveness. And I think that's what is critically important, and why 2.0 is so critical in the days ahead. So from my perspective, this is what I wanted to say, and we can move on with questions. Okay, are we all available? Yes, we are. And from my just last comments, I would like to bring Lucy in the by giving us some light as to how the manufacturers of vehicles in Europe feel in this paradigm change of electric vehicles becoming active components of the interconnected electrical grid. How do they look at it? How do they react to it? And what do you think is their commitment towards this direction?
Well, as you know, I'm not representing only OEM, so I will try to answer to these questions, but maybe I'm not the best contact to really provide the perspective of the different European OEMs. I think the changes that we will face in the, let's say, coming decade, this is really a major change. And as it was mentioned many times, it's not only a change in terms of propulsion system for the vehicle, but it's a change of how we will use the vehicle, how the user will use the vehicle, and what benefits they can get also from switching to e-mobility. So I would say, at least from the discussions I had with many of our members, they see this as a challenge, a very important challenge, but also a lot of opportunities. But from their side, I think the message that should be conveyed is that there cannot be uptake of electric mobility without large-scale deployment of recharging infrastructure. And I think this is the main challenges that they are facing today is that we don't see enough charging infrastructure in the street, fast charging or slow charging, because both solutions will be needed. So yeah, I'm not sure that fully answer your questions, but
Yes, thank you for this answer, Lucy. The thing that what I realized from my participation in the 2.0 discussions is that I have realized that the manufacturers have understood the benefits of this shift towards the system approach. I'm very positively, let's say, influenced from what they are saying and what they and how they are approaching it, and see the value of playing a role in this direction, because they see the economies that are coming positive in their direction through this, let's say, shift of technology exploitation and utilization. And so, to my understanding, they look at it very positively, because they see into it that they will make European manufacturers more competitive and more, let's say, in line with what their competitors are doing, because they are already doing it as well. And so they see through this process that it is a winning process for both in all directions.
yeah, I
So
think it's clear for everyone now that we cannot turn the road transport system towards electromobility without working together, automotive and the energy side, in a system approach. I think this is something that is now well accepted by all players. Yeah, for sure.
Yeah. Any comments from any one of the participants here on this issue? Yes, please, Evangel.
Is that I think that OMCV manufacturer has to play a key role, because charging is not only the charging process itself when the EV is connected, but also charging is prior the charging process as well as a posteriori the charging process. And when we are talking prior the charging process, we mean the accessibility. And when the vehicle is not connected, the user needs to have services on how to optimally and conveniently access the charging infrastructure in order to reach the destination. For example, a routing service, in order to make the best decision to guide the user, the EV driver, to the destination, needs to have information from the car. Otherwise, this information from the battery management system, the consumption for profiling the user, or the state of the charge of the battery, needs to be provided by the user, which is not the best option. Always ask the user for information. So providing information by the EV manufacturer will provide the concept of, let's say, the extended vehicle, in order to be able to provide services to the user before connecting to the charging station. And then imagine that a driving vehicle is a future load, not only a future load when it will be connected to the grid in order to forecast the demand, but also it's a potential flexibility that will be connected in a few minutes or in a few hours in the grid. So knowing the driving profile and the status of the car before connecting, we can forecast the demand in the grid as well as the flexibility that is coming in the near future. So the strength of the EV manufacturer right now is the data they have from the vehicle and how they will share them with the other stakeholders, EMSPs and CPOs, as well as energy actors, DSOs or energy suppliers.
Yeah, thank you for that, Evangele. Any other comments from anyone? Okay. Yeah, please.
Maybe I have a short comment myself. I think I try to explain that there is all an ecosystem around the electric vehicles. Of course, each one has to take his own role and make the progress. Enormous progress has been made in the last few years, and that's why we have these very ambitious target and nice scenarios of 2030 penetration of electric vehicle in our fleets. Of course, one important aspect that is the battery is a major cost of electric vehicles still. So it's important to make sure that all the charging solutions that we are studying and proposing are not affecting the durability and the aging of the battery. We have to provide certain information to the user that by having slow charging or even fast charging, the battery is not in harmful situations, so they can last as expected. But it's also, of course, important to involve the OEM because it's important to extract all possible information about the life extension of the battery, the state of charge, and the situation, and also for planning the charging properly. We said that most of the car will be in idle for a long time. This is really a great opportunity for the system because if they are idle and they are connected, you have the data and you have the energy available in case the system needs in what you said, like a peak shaving, moving the peak away from where the usual load is happening. So even in time. Thank you.
Thank you, Luciano. Let's go to Jose, who is the, let's say, the technology provider here. Being a technology provider with the solutions you have described to us, what do you think, because I'm sure you have thought about it, what are the challenging technologies for you to achieve, let's say, to contribute to this energy transition of moving towards 100%, let's say, e-mobility in the years ahead? But for you, currently, in 2021, and seeing what you have achieved with your technologies, what just for us to see what is the thinking of a technology provider in responding to these needs and to these requirements?
Yeah, I believe the one of the most important things, it has been mentioned here, the concerns about EV charging infrastructure, and I believe one of the most important things from the side of technology is to have smart chargers, because we must have access to curtail power available from the charger, and we must have the visibility on the demand from the grid side, so we can combine each other and we can improve. We can make it higher the number of the DVs in our streets. So I believe that one of the points.
Any other contributions from anyone on what we consider as priority issues in technology evolution in support of the electric vehicle transformation? Any ideas? Yeah.
In my previous comment, I was talking from the car side. Now I have to come closer to what Lucy just said before, the charging infrastructure. These really need to be developed in this year if you really want to have a user buying as a new car an electric vehicle because they are confident that they can either recharge at home or at their working place or when they are traveling. So it's important to make the planning of this charging infrastructure at best in order to use the present grid the most is possible and to make a reinforcement in case they are needed on specific points. I think charging cars during working hours is a very good solution because they are idle, and usually you can find maybe also fancy and costly solution. But then maybe having a really dispersed infrastructure that allows you to charge your car when you are at the supermarket, when you are in parking your car in downtown your city is very important, because I tell you that there is still the anxiety to be sure that you can arrive at your final destination with the charging of your car. So you must be sure that along your trip you find a place where you can charge your car at reasonable cost and for a reasonable amount of time, not longer time that making the trip too long. Research infrastructure, we analyze the situation could have an impact in terms of power, not in the term of energy. So when we were making the study for NSOE, we were really making sure that the most maybe aspect that need to be considered is the peak power that the cars can get from the grid, not the energy, because in the end there's still a moderate amount of energy for a transmission system. Nevertheless, the good planning and optimal planning is something that would be at the basis for this rollout of massive deployment of electric vehicles. That is true. Thank you.
Yeah, thank you, Luciano. But I think that from the angle of electric mobility, there is the need for, let's say, vehicle-to-grid technologies to be optimally developed, and from the side of the vehicle to offer this technological evolution. But I think what is more challenging and more demanding at the moment, and more, let's say, pushy to achieve, is to make the grid smart enough to offer smart charging. Because without smart charging, e-mobility is going to be, let's say, slow picking, because you cannot utilize the capabilities of the grid smartly, and thus you will be asked to lay more copper or to strengthen substations capabilities and things like that, which is not the correct way. And so there is a push and there is a need for the evolution of the system and picking up in the direction of being smarter. And so this brings me to ERA Joint Program Smart Grids that you are chairing. And how far did we go in this direction, you think, in providing solutions that resemble Web of Cells? And I bring it to the attention that we have worked on that, and we have developed solutions in that direction. And we have shown that it's possible to do that, but we haven't seen them really picking up in real life. And because you have chaired this research program, and I know that a lot of valuable work that has been published, but we don't see utilities picking it up. Why, you think?
Thank you, Venizelos, for bringing it up. Coming back to what you just said, I think smart charging is a must. It's not something that we would like to have. It's a must. If not, you add an additional burden to the grid by the EV extremely low and an additional load that you have to serve. And the vehicle to grid is something nice to have now, but will be mandatory in the future because of the million of cars that will be on system. According to what you said, in the ERA JPO Smart Grid, we look to distributed energy resources, and the EV car is exactly like that. Could be a load a certain part of the time of the day, and then could be an important generation point because of the battery. So I think the Web of Cell, that was a concept that we developed for distributed energy resources, could be also applied in order to allow for some optimization at local level before the main grid is asked to support the situation. So I think if you solve all the possible problems at local level, will be more efficient and with less need for investment. Of course, and then if you cannot solve a certain problem at local level, then the main grid should intervene. But is really maybe a chance that 80% of a situation can be solved locally. For example, using the web of cell, that is like allowing a local operator to use flexibility in a very smart way, combining what is the situation of different cells within his responsibility. So he can really make sure that there is an exchange in between different area of the grid in order to minimize the difficulties. After that, you of course can ask for main support from the transmission system. I think as ERA JP on Smart Grid, you are leading one of the sub-program that is exactly dealing with the demand side management and all this stuff. This is part of the demand side. So I think electric vehicle will be maybe the most important tool to make what we believe is important as a system integration. The first system integration will happen between electricity system and transportation because of the electrification of transport. And the car will be seen as a very valuable demand side response, let's say opportunity, because user of the electric vehicle, they know when they need the car, and the time we don't need the car, they can be flexible enough in their consumption in order to support the grid. Of course, these need to be remunerated, these need to be evaluated, but it's some business model we are studying. I think it will be very positive and very possible to be applied in the near future.
Mm-hmm.
Thank you, Venizelos.
Yeah. And I think from what Luciano has just said now, it shows that the research and innovation is critical in our lives and is critical in this energy transition, which brings me to Evangelos to see, because he looks at it from the research and innovation angle, the evolution into e-mobility. So what do you think are the main challenges ahead of us in research and innovation? Because Lucy is listening very carefully. 2.0 is for research and innovation. What do you advise Lucy to do in this direction? Yeah.
This is a very good question, because we have to check both directions. I mean, not only the technologies, but also the systemic approach and the interaction with all the other systems. We have really deep knowledge and great experience how to handle flexibility, not e-mobility related. I mean, we have done a lot of research, decades right now, how flexibility coming from homes, from tertiary building, how this can be exploited from different service providers, how it can be aggregated, all the tools, all the services, all the interactions, all the standards are in place. First of all, we need to extend them in order to include e-mobility in this context of exploiting it, utilizing and valorizing flexibility, EV flexibility. Mm-hmm. From technological part, I think that technologies right now for the charging and the smart charging process are really mature. Where the focus is, and this is reflected also in the Horizon Europe, are the bidirectionality, the vehicle-to-grid technologies. Mm-hmm. We need to improve, first of all, the power losses and the efficiency of such technologies. And there is a question, right now there is only DC, bidirectional power flow. Mm-hmm. Should we focus on DC or on AC? Mm-hmm. Which is better? Which provides lowest cost solutions? So the first part of the technologies is to improve the cost for the V2G, that technologies that enable V2G, and improve also the efficiency by minimizing the losses. And this can be done through implementing innovation power electronic technologies, mm-hmm. new switching devices. Yeah. From the vehicle point of view, we also need to improve the battery management system, but we need to identify and we need to consider when V2G, under which circumstances V2G is viable or not, because discharging the battery is an operation that is not the normal operation for an electric vehicle. It's an additional one for profit maximization or for grid favor, but we need to define, to identify, to model the battery in order to capture and specify clearly and transparently the aging effect of this discharging process.
Yeah.
And we need to remunerate this degradation of the battery and be considered in any smart charging V2G oriented service that will be developed. And coming to the system approach, I think that the architectures, the systems are in place, as I mentioned in the beginning, because we have the great paradigm and experience from the distributed resources control and the flexibility that they can be provided at home and at tertiary level, tertiary building level. So I think that what we need to do is in all these concepts that already exist to include electric vehicles, extend them, this communication and these interfaces with the specific data models, as well as the responsibilities of all the actors to be transparent and with clear responsibilities and clear interactions. Thank you.
Lucy, here a mouthful of recommendations from Evangelos. Are you happy
Yes.
about it? Are you happy about it?
Yes, I'm very happy. I think most of the item you mentioned is topics we extensively discussed also sometimes during the 3-year preparation for the 2.0 partnership. So I think this is well aligned with everything that we are planning to cover. As I was mentioning, the first work program is already set, and we have this topic that is published that you mentioned also in your presentation, Evangelos. And we hope that we will be able to cover all the items that you listed. Of course, we have limited timing and limited budget, and this is a constraint we also need to consider. But especially I'd like to just come back for 1 second on the V2G and the battery degradation. Of course, this is a very important topic. As a matter of fact, just this morning we had also an internal discussion, and we mentioned again testing needs for battery degradation, something that we expect to work on also involving the GRC. And for this, we will also need, as I was mentioning during the presentation, strong interaction as well with the batteries partnership. So there will be also opportunities to collaborate also with other partnerships so that we can benefit also from their experience and from their activities, also to measure what will be the impact of discharging on battery degradation and lifetime.
Mm-hmm. Thank you, Lucy. The audience, do they have any opinion on all what you are hearing? Okay, I don't see any reaction. Luciano would like. Please, go ahead.
Kind of breaking the ice. No, I want to connect to a very important aspect that is data. So when we talk about smart charging or vehicle to grid even more, everything is based on exchanging data, so having platform in order to know which is the status, to receive signals. And so all the data related to ownership and privacy and whatever are very important aspects. So I think dedicating time to this important aspect will also facilitate this new functionality to be put in place, because of course you are the owner. If you share your data because you get some benefit, you do that. If you don't get any benefit, why you have to share something that is yours for the benefit of some other stakeholder, some other player? So I think it should be like a win-win situation where you provide data about the battery status, about your trip, about your habits, and then you get as a reward a cheaper price for a car, a cheaper price for your recharging, anything else. I mean, I think this is a very important aspect. Also, to have some regulatory framework that allows you to share this data in a very secure manner on an interoperable platform and so on. So this is an aspect that maybe we as ERA JP on Smart Grid should be focusing more and more because of course everything need to be researched in this aspect. Thank you.
Yeah, I think you have touched one issue there that within ERA Joint Program Smart Grids, e-mobility should come strongly into it, because EVs now, they are going to be part of the system, and it's going to be bidirectional, and it's going to be playing a very important role in how we develop the system. And it's not only, it's not from the generation side that I'm talking about, is the operation of the actual, the 10-year plan that we will do with the transmission system, the distribution system is affected by that. And so that gives us a substantial area of really research work from the grid side, not from 2.0 side, but from the grid side. Yeah.
You
And
always talk about flexibility. This is really an amazing opportunity
Yes.
for having new resources for flexibility.
yeah, yeah.
If I
So,
can just comment.
of course, yeah, please.
Yeah.
Yeah,
To
Jose,
complement
please.
what Luciano was saying, yes, it is very important how we manage data and how we put data available to other stakeholders to work with that. That's definitely the major challenge. We have a lot of countries in Europe with systems in place already to provide the visibility on the demand and on the constraints. In particular in the UK, we have a good picture of where are the major constraints in the LV grid, so we can predict how can we for how long and for how many can we charge EVs in the grid. But then there are a lot of issues that will come up with e-mobility growth. One of them, it was not mentioned yet, I believe, is the voltage level in each point. So it would be very beneficial for the system to have the voltage levels from each smart meter if it is available, but of course it is dependent on the privacy discussion, the privacy results, and how can we make it available to be consumed from other systems, in particular to decide if we can make a charger available to deliver full power or not. And this is I believe these are the major challenges to allow a huge growth on the EVs, on the e-mobility. I believe that's a concern that a lot of countries are working on that. In Netherlands, for instance, there are the electricity regulator and the privacy regulator working both on this. Just to name an example.
Thank you, Jose. So I think we have gone round a good round of questions and answers in addition to our presentations. And I think we have reached a level where I consider that we have covered the objectives of this workshop. So I'm ready now to just hear some last words from all of us. So can we start with Evangelos? Any last words on this workshop that we had today? And I hope you all enjoyed it, but any last words?
First of all, I hope that I'm sure that we had a great discussion, great opinions were heard from all of you. And I would like to thank you that I was joining this discussion. It was an honor for me. I think electromobility is the future, and I think that such discussions can be endless. There are many topics to be discussed, many issues to be solved, but electromobility came and will be the future, and we will still discuss it for many, many years.
Good. Luciano?
Join Evangelos in saying that I think it was very nice to decide that this topic for this workshop is a very hot topic for us. You put all the distinguished speakers all together. Thank you very much, Venizelos, for that. Of course, we touch just the surface. Many of the topics need to be, of course, a much deeper discussion. I think we covered the most important one. I think research and innovation is very important. So RTOs still have a role to play, because some of the solutions that are still at the laboratory scale could become ready for mass deployment shortly. We didn't talk very much about interoperability, but of course it's an issue. I have a new car, I have 2 cables in my car already, and I have an adapter for charging at home. So this is okay at the very beginning, but then the final user doesn't want to have all the trunk filled in with the cables. They want to have the trunk for the other stuff. Nevertheless, it's just the start. We are making this kind of interoperability study. For example, we have 24 charging points provided by 5 different suppliers. So we test different suppliers. And I think this is what we need in order to get confidence that the system is really interoperable. Your car can really connect at different places according to your need. And we will be working on this topic in the years to come, because it's really a very important topic for the system and for the user. Thank you.
Good, good. That's good. That is so promising, the words. Jose, what do you think?
Okay, thank you. My last words, I would say that EV, e-mobility growth is completely a reality, so we have to be prepared for that. At some point, it can compromise the security of supply at some circuits. But of course, technology are already made available to solve it. So it's just a matter of discuss the interoperability, the data management, the data privacy. How can we make it available for other stakeholders in order to provide to the citizens the chance of using electric vehicles only.
Yep. Okay. Did you hear enough, Lucy? You think, what are you taking back to zero?
Well, I think I will have to go back to our members and explain to them once more that flexibility is a key word and that we have to do more in this direction. I think it was nice to have this discussion, and I think it's very nice to see these two communities getting together and starting to speak a little bit more the same language, I would say. And I'm quite confident that we will be able to do more in the future. And I just would like to invite again everyone to be involved also in the discussion for 2.0, because it's nice to have this exchange of views, but it's also very important that we have more and more players from the energy side also joining the partnership and bringing their views, because this is also the way forward to achieve what we expect and to achieve this flexibility that we need. So really, I can only invite you to join future projects, to submit proposals, and to be involved in the upcoming activities. And on a side note, I'd like to thank you again, Venizelos, for the invitation today, and also for your commitment in the 3-year preparation of the partnership.
Yeah, our pleasure, Lucy. You know that. And from hearing you, I think that is of critical importance to find ways of supporting the process. And so, although you have already said your words, what do you think, or how you think interested people can help 2.0? How? If they are not members, because members, okay, so is normal, is natural. How?
Yes.
And you have 99 members, if I remember correctly the number.
That's right. We have a lot of members. We still miss some members from the energy side. So in any case, anyone is always welcomed, but even more from the energy side, I would say, really to bring also this additional perspective. But beyond, we have a public newsletter. You can register. You can join upcoming events that we have. Evangelos mentioned several projects that as a matter of fact, have been funded as part of the green vehicles, and we try to present the outcome of this project. And it's always nice that when we have discussion also about project outcomes, we get also questions from a different angle, a different perspective, so that we can also adjust the priorities, the definition, and the way we explain the challenges in upcoming topics, so that we can also make sure that the views and perspective of the energy side and the grid side are also well considered when we define future topic, because we can define challenges from the automotive perspective. This is fine. This is a very important aspect, but we also need to properly consider the challenges that are faced by the grid, so that in the end we have challenging topics, but we also include in topic description in the challenges and the areas to be covered also the key topics and the key challenges that we need to address. Also just join the events we are organizing, and try to submit proposal as well. We have now this topic on system integration and V2G. We will have also probably one topic related to charging as part of the city's mission. We are still expecting a final confirmation from the Commission on this, and I hope you will see more and more topics also related to integration between automotive and the energy in the upcoming work program. And there we need also the experience and the expertise from many players also in project. This is really the place where we will make most of the contribution from the 2.0. Publishing the work program is one thing, but in the end, the work is done by funded projects. So we really need the right experts on board as well.
Okay, well, very good. Thank you very much all for this contribution. I think from the side of the organizers of Cretan Energy conferences and what we are trying to do here, I would like to thank you all for connecting today. I think it was an interesting discussion. We have touched on an issue which is hot at the moment, as already indicated by all. Is a change that is welcomed. I think people are very positive for electric mobility, and so I think that progress is going to shift quickly as we move along, and situations like this, conferences like this, where we touch on and we talk about it and we share experiences and knowledge and information, I think is of critical importance. So I would like to thank you all for connecting. Everything will be available, even it will be recorded and shareable. So we will hear connection of how to get the proceedings of this event that we had today. And thank you for connecting and being here. Thank you all.
Thank you, Venezuela. Thanks also to the other organizers, Christina, and thank you.
Okay.
Thank you.
Bye-bye.
Bye-bye.